Hi, today I want to talk about how to determine if the substituent added onto a benzene ring is an activating or deactivating group. So, some general rules to follow for activating groups is that they donate electrons or electron density into the benzene ring, therefore activating the benzene ring. So some strong cases are nitrogen, since they have lone pairs, and this could be attached to two hydrogens, or it could be attached to two different R groups. And there's also the case of oxygen, because oxygen also has lone pairs. And likewise, it can be attached to a hydrogen, or it can be attached to another R group. And so one thing to note is that for these strong activating groups, they are directly attached onto the benzene ring. So for the case of oxygen, the oxygen would be right here, and there might be a substituent attached onto that oxygen. But the important thing is that the electrons are directly attached, that way they can have resonance. And so moderate groups are similar to the strong groups, except for that they are attached to an electron withdrawing portion on the other side. So something like nitrogen attached to a carbonyl group here. So likewise, the lone pair can still donate electrons into the aromatic ring. However, there's also the possibility that the nitrogen lone pairs are donated to the right, which would then resonate this up to the oxygen. And so it's not as strong because there is a way for the lone pair to not be donated onto the benzene ring. And this is a similar case to oxygen if this is attached to carbonyl. These electrons would be able to donate to the benzene ring as well as to the carbon here, forming a double bond and pushing these electrons up there. And for the weak cases, they are mostly just donating electron density through hyperconjugation. So that could be a methyl group, so CH3, or anything with like a lot of carbons. So even an aromatic ring can be considered an activating group if it's attached onto another aromatic ring. Moving on to the weak deactivating groups, we have the halogens. And so halogens are weakly deactivating because they pull electron density away from the aromatic ring, therefore deactivating the ring. And so they can also have lone pairs, which will be important for later. And so the moderate groups are the groups that are like carbonyls, where they can resonate the double bond from the aromatic ring on here and then pushing this up here. And if I draw that out for you, we can see why that is the case. So carbonyl up here, and then so resonance is possible from this double bond pushing this up here, which will form a structure where the aromatic ring is no longer as electron rich as it would like to. Whoops. So this would be an O minus, and there would be a double bond right there. I'm going to positive charge here. So as you can see, the aromatic ring has a positive charge. Therefore, it is not as electron rich and won't participate in reactions as much. And that's why this is a deactivating group. And so this carbonyl can have other things attached to it, say like a halogen or an R group, which is essentially just having more carbons attached, as well as it can have an oxygen or nitrogen on that side. So in this case, you have to be careful comparing the deactivating moderates with the activating moderates, as they are very similar. However, it is the position in which the carbon or atom is attached onto the benzene ring that matters. And so moving on to the strong deactivating groups, we have carbon with 3 fluorines, as well as nitrogen with 2 oxygens, and a positive nitrogen in that case, which is attached to our 3 R groups, or 4 actually. because there's the benzene ring attached on as well, giving the nitrogen a positive charge. And so the trifluorine is electron withdrawing because of induction, because fluorine is very electronegative. So it pulls electron density away from the aromatic ring. And so nitrogen, if you draw it out, nitrogen will have a positive charge, and it's connected to an O like that with the minus. And so the separation of charges leads nitrogen to be positive. And so it'll take electrons away from the benzene ring as well. Therefore, it is a strong deactivator. And the nitrogen attached to 4 groups is the same reason, being positive. And so I want to talk about how these groups will affect adding a second substituent on. So if one of these groups, whether activating or deactivating, is already on the benzene ring, how will that affect the addition of another substituent? So it's easy to just remember that everything from strong activating, moderate activating, weak activating, to weak deactivating are all ortho-para directors. And so that means the moderate and strong are meta-directors.